Chemical rockets. Chemical rockets are a type of rocket that uses a chemical reaction to generate the high-velocity jet of gas that propels them. The reaction is typically exothermic, meaning that it releases energy in the form of heat, light, or sound. The energy released by the chemical reaction is used to heat and expand a gas, which is then expelled through a nozzle to produce thrust. Chemical rockets are the most common type of rocket and have been used for a wide variety of applications, including launching spacecraft, launching missiles, and propelling vehicles such as cars and airplanes. Some common chemicals used in chemical rockets include liquid hydrogen, liquid oxygen, and solid rocket fuel. Here is a schematic diagram of a chemical rocket. A fuel and an oxidizer are loaded into the rocket's tanks. The fuel is a substance that can burn, while the oxidizer is a substance that supplies oxygen to support the combustion of the fuel. The fuel and oxidizer are pumped into a combustion chamber, where they are mixed and ignited. The chemical reaction between the fuel and oxidizer releases a large amount of energy, in the form of heat, light, and sound. The hot gases produced by the chemical reaction are expelled through a nozzle at the back of the rocket. The shape and size of the nozzle determine the velocity and direction of the gas flow. The reaction of the gas flow with the atmosphere produces a force in the opposite direction, known as thrust. The thrust propels the rocket forward and upward. The rocket's guidance system helps to control the direction of the thrust, allowing the rocket to change its course as needed. As the rocket uses up its fuel, it becomes lighter and its acceleration increases. This allows it to reach higher altitudes and speeds. When the fuel is exhausted, the rocket's engines shut down and the rocket coasts to its destination, using the momentum it has gained. Nuclear rockets. Nuclear rockets, also known as nuclear thermal rockets, are a type of rocket propulsion system that uses a nuclear reactor to heat a working fluid, which is then expelled through a nozzle to generate thrust. Nuclear rockets have the potential to be much more efficient and powerful than chemical rockets, which are currently the most commonly used type of rocket. However, they also have some significant technical challenges and safety concerns, which have so far limited their use. Here is the schematic diagram of a nuclear rocket. A nuclear reactor is used to generate heat by inducing a controlled nuclear reaction. The reaction can be either fission, in which the nucleus of an atom is split into smaller pieces, or fusion, in which two atomic nuclei combine to form a heavier nucleus. The heat generated by the nuclear reaction is used to heat a working fluid, such as hydrogen or helium gas. The gas is typically heated to very high temperatures, on the order of thousands of degrees Celsius. The hot gas is then expelled through a nozzle at the back of the rocket, producing thrust in the opposite direction. The thrust propels the rocket forward and upward. The guidance system helps to control the direction of the thrust, allowing the rocket to change its course as needed. As the rocket uses up its fuel, it becomes lighter and its acceleration increases. This allows it to reach higher altitudes and speeds. When the fuel is exhausted, the rocket's engines shut down and the rocket coasts to its destination, using the momentum it has gained. Nuclear rockets are not currently used for operational spaceflight, but they have been tested in the past and are considered a potential option for future missions that require high specific impulse, such as interplanetary travel. Here is the major comparisons between chemical rockets and nuclear rockets. Firstly, the energy source. Chemical rockets rely on the chemical reactions of fuel and an oxidizer to produce heat and generate thrust, while nuclear rockets use the heat from a nuclear reactor to power their propulsion. Secondly, the propulsion mechanism. In chemical rockets, the heat generated by the chemical reactions is used to heat a gas, which is then expelled through a nozzle to generate thrust. In nuclear rockets, the heat from the nuclear reactor is used to heat a working fluid, which is also expelled through a nozzle to generate thrust. Thirdly, efficiency. Nuclear rockets have the potential to be much more efficient than chemical rockets because they can produce a much higher temperature and generate more thrust for a given amount of fuel. Fourthly, safety. Chemical rockets are generally considered to be safer than nuclear rockets because they do not involve the use of radioactive materials. However, nuclear rockets also have safety features and measures in place to mitigate the risks associated with their use. Last but not the least, the cost. Chemical rockets are generally less expensive to develop and build than nuclear rockets, due to the complexity and cost of building and testing a nuclear propulsion system.